Hey, it's Tyler from Manifold, and next up we're going to talk about the Bitcoin integration that is capable with our serverless blockchain. Our system computes standard block hashes for every transaction and stores those hashes inside the block table that we have defined in DynamoDB. And in addition to just standard block hashes, we have two other forms of hashes within our system. Those are going to be meta hashes and uber hashes. Now, those are very similar and related, but the main difference between them is that the meta hash is going to be a single cryptographic hash inclusive of all events and transactions on the full blockchain that have taken place over the previous hour. Whereas the uber hash is going to be a single cryptographic hash that's inclusive of all events and transactions on the blockchain over the previous 24 hours. Now, it's this uber hash that is written to the Bitcoin blockchain once a day when we've enabled Bitcoin integration when we initialize our blockchain. Now, how exactly do we go about initializing with Bitcoin integration? Well, take a look at our documentation here, and we've got the first init command called out here, but if we scroll down just a little bit further, this is going to be the command that we need. And so I like to copy this. I'm going to drop it into my text editor, and that's what we'll work from up here. All right. Cool. Now, taking a look at this, the primary difference in this initialization command, it's going to look very similar. We've got the admin, the password, the currency. Big difference here is going to be the two wallets that we have called out. We've got our wallet 1, wallet 2, and this network parameter that we've also got defined right here. Now, the reason we need two wallets for the Bitcoin integration to function is because the method we use to embed the uber hash into the Bitcoin blockchain is by including that as metadata to a Bitcoin transaction that we submit. Now, how do we generate that Bitcoin transaction? Well, that's by sending a minimal amount of Bitcoin from wallet 1 to wallet 2. The cost, and that is to say the funds that are spent as part of that transaction, go to the miner that includes our transaction within their block. And that's in the form of transaction fees. Okay, so for my demonstration here, I've generated a couple of testnet key pairs and then used a testnet faucet to send some of those testnet bitcoins to both of those wallets. Now, before we go ahead and call the init function, I want to take a couple of seconds just to show you where you can find those WIF encoded private keys. And so to do that, I'm going to launch Electrum in testnet mode, and I do that by passing testnet in as the argument. Okay, now that steps us into the default wallet view. We can see we've got some funds in there, and that's funds I received from the wallet. But if we come up to the top in the wallet, under private keys, we get export. All right. And this is going to show us the list of key pairs associated with my address here. Okay. Now these values that we see over here are the WIF encoded private keys. And the way I pick the one I'm going to use is I look over here at my receive address. All right. Come back up to my private keys. All right. And then I just look for the one that corresponds to that. So this one's ending in BVX, wallet, private keys, export. Sweep all those out. BV ending X. Here we go. Cool. BVX, bam. So that's going to be one of the private keys that we use. All right. And so I take this address. All right. I come into my, go into our testnet faucet, paste that address in there. Tell them you're not a robot. Send some coins. And now we'll get some more money into that wallet. Cool. Now, let's go ahead and build our command. All right. So I take those private keys, paste them in here. They go directly into the command line itself. All right. Testnet. I think this init should be. And put this all on the same line. Alright, we gotta make sure we've got a valid password, so secure pass 12 currency, we'll call this one test coin again. For the amount, we'll pick a lower number. How about just 1 million? Alright, so we'll take this, copy to our clipboard. We're going to jump in here. Now, just as we did before we initialize this command, let's make sure we're talking to the right AWS organization. Information describe stacks. Alright, that's what we like to see. Just paste our init command straight in. It goes according to plan. That's what we like to see. No errors returned. Let's take a look at our init.log. And there we have it, using the Bitcoin test network. Bitcoin integration enabled. And so, end result of what this looks like is that if you're watching that wallet file while it's in use, you'll be able to see transactions show up on a daily basis with the Uber hash attached to that. And let me show you what that's going to look like. And so to do this, I'm going to switch to my Electrum wallet so that I'm no longer going to be looking at a testnet, but go to a real network address. All right, this is a real and so what we're looking at here is our real network address. And this I had up and running for, over a couple of months. But we can step through this and then see all of these transactions that get added and the minimum amount. Our balance descending over time, and that's mostly a function of money getting transferred over. So once our balance gets low enough, you could just send a transaction from wallet 2 back to wallet 1 and just keep going. The only thing that's really lost is the transaction fee. But if I open up one of these transactions in here, details, and we can view this on the Block Explorer, we'll be able to see the Bitcoin transactions that had been submitted as part of that block. So this is our address right here, and this is the Uber hash that had been written to the Bitcoin blockchain. We did that. So that covers our Bitcoin integration. Thanks for your attention.